China launched a robotic mission to the far side of the moon, and it sent back some incredible images. Let's break down Chang'e-6, take a look at those photos, and talk about why this mission is such a big deal. Chang'e-6 is an uncrewed mission to the far side of the moon. This is the second mission that China has launched to the far side. The first was Chang'e-4, which successfully touched down in 2019. This is the second lunar sample return mission for China after Chang'e-5, which launched in November of 2020. However, this is the first sample return mission ever for anybody from the far side of the moon. The spacecraft consists of a few different parts. There's an orbiter that stays in lunar orbit, a lander that separates from the orbiter, targeting the Apollo crater in the South Pole-Aitken basin on the far side of the moon, and that collects samples, an ascent vehicle that launches from the lunar surface with those samples and conducts an autonomous rendezvous and docking with the orbiter, a re-entry capsule that will receive the samples and then safely descend with them back to the Earth's surface, and a surprise, a lunar rover that we only learned about after the mission launched, because Space News reporter Andrew Jones noticed in photos from the spacecraft manufacturer, the China Academy of Space Technology, that there was a rover on the side of the spacecraft. As you can imagine, it can be a little bit difficult to get information on the Chinese space program. I do follow the CNSA, or Chinese National Space Administration, but I often turn to Andrew's reporting to help me make sense of what's going on. So if you are interested in reading more or following the Chinese space program, I highly recommend looking up Andrew's work. I'll drop a link below. Chang'e-6 launched on May 3rd and entered elliptical orbit of the moon on May 7th. It's been orbiting ever since, waiting for its chance to send its lander to the surface. Light conditions were very important here. The far side of the moon is often called the dark side of the moon, but it's important to remember it's not actually dark. That side of the moon just faces away from the Earth all the time because the moon is tidally locked to the Earth, so we only ever see one face of it. We never see that far side of the moon from here, but it is illuminated by the sun in the same manner the near side is. The sun rose on the South Pole-Aitken basin on May 27th, so it seemed that the Chang'e-6 landing would be in early June. The South Pole-Aitken basin is the largest impact crater on the moon, and in fact, it's one of the largest known impact craters in the entire solar system. The aim for Chang'e-6 is to study the significant differences between the far and near sides of the moon. China's also preparing for crewed missions to the moon. They're hoping to launch their first mission to the moon with taikonauts aboard by 2030. Chang'e-6 was targeting a crater within the South Pole-Aitken basin called Apollo, and late in the day on June 1st, that's 6:23 p.m. Eastern or 22:23 UTC, that would be 6:23 a.m. on June 2nd, China Standard Time. The lander successfully touched down on the moon's surface. This was the third lunar landing in 2024 after Japan's Slim and Intuitive machines, and the first this year to not topple over in some manner after landing. Here are the first photos we got from the landing. They're breathtaking. A couple of important things to note. The curvature of the moon in this photo is because of the wide-angle lens. You are not seeing the curvature of the moon. The moon is brownish in these photos because the moon is brown. This is a photo taken in the visible light wavelengths. We are all used to thinking of the moon as gray, but the moon does have color. The color, like anywhere else, depends on what surface minerals you're looking at. But we often make assumptions on the color of the moon based on photographs we've seen. But the color in photos can depend on white balance, on exposure, plus a good number of images from the Apollo era were black and white. Additionally, dust particles can make things look white because of the way they reflect light, and we know the moon has a lot of dust. Here are a couple of Apollo photos that illustrate this. Here's Apollo 15's Jim Irwin with the lunar rover. And here are two side-by-side photos of Charlie Duke's family on the moon's surface. Notice the difference? Back to Chang'e-6. After touchdown and a checkout of its system, the lander started collecting samples. We know that the lander collected up to 2,000 grams of samples, both from the surface as well as from drilling down. At some point during all this, Chang'e-6 also released its rover, and they even gave us a photo of the lander on the lunar surface as taken from the rover. It's pretty spectacular, but we don't actually know what else the rover is up to because the CNSA hasn't provided that information. The surface mission was expected to last about 48 hours, And at 7:38 p.m. Eastern Time on June 3rd, that's 23:38 UTC, the Chang'e-6 ascent spacecraft lifted off from the moon with the samples on board. You may be wondering how China's getting all this data back, as it's very difficult to communicate with a spacecraft on the far side of the moon because it's always facing away from the Earth. Well, that's thanks to the relay satellite Chang'e-6, which launched back in March. The satellite relays signals to and from the far side of the moon, including data transfers for these photos. The satellite will also be used for future lunar missions, including Chang'e-7 in 2026 and Chang'e-8, which is scheduled for 2028. Chang'e-2 also provided the Chang'e-6 ascent vehicle with autonomous positioning and attitude on its journey from the lunar surface. The ascent vehicle docked with the mission's service module in orbit. After docking, the sample canisters autonomously transferred to a special re-entry module that happened late in the day on June 5th, US Eastern Time. Then the service module will begin its trip back to Earth, probably sometime in late June. We don't have exact dates on this, but the mission will likely be around 53 days total. If the samples are returned successfully to Earth, these will be the first samples from the far side of the moon ever. China's space program is booming right now, and they have a very successful lunar landing program, with 4 successful landings out of 4 attempts. They're planning on an asteroid sample return mission, Tianwen-2, in the future, and for Tianwen-3, a Mars sample return mission in the 2030s. If you've seen my video about problems plaguing NASA's Mars sample return mission, if you haven't, check out the video, you might be wondering, why doesn't NASA partner with the CNSA for MSR? Well, they can't. The Wolf Amendment passed by the US Congress in 2011 specifically prohibits cooperation with China on matters involving space. Specifically, NASA cannot allow its funds to go towards any projects with China or Chinese-owned companies. The only way around this is that NASA has to certify that there's no risk of sharing data or technology with China, and that nothing includes any Chinese state officials who have been involved in human rights violations. On one hand, I do get it. But on the other, this amendment hasn't stopped Chinese space development, and would working together help more than refusing to work with them? It's important to note that Chang'e-6 is an international collaboration. NASA just wasn't involved. Payloads from Sweden, Pakistan, France, and Italy were included aboard Chang'e-6. That being said, NASA did encourage researchers to apply for access to use Chang'e-5 samples in their research, stating that it had provided the necessary documentation to Congress for NASA-funded scientists to use these samples. So that is a huge step. Let's hope they do the same for the Chang'e-6 samples, because there is going to be so much cool information within this lunar regolith. And that is just about all I have to tell you about the Chang'e-6 mission. Thank you for watching. I am Swapna Krishna, and this is Ad Astra.